Let's try a couple of applications of linear systems. In example 1, suppose that the sum of two numbers is 12 and that the larger number is 3 less than double the smaller number. What are the two numbers? I'm going to start by defining two variables. We have a larger number and a smaller number. So how about I let x equal the larger number and y will be the smaller number. This is a good starting point because now we can create equations using x's and y's, because the sentences that appear here are kind of confusing. So suppose that the sum of two numbers is 12. So this very first portion of this first sentence tells me that if I have two numbers and I'm calling them x and y, and their sum is equal to 12, I pretty much get my first equation pretty easily. X plus y is 12. All right, but if we have two variables, we're going to need a second equation. So the second part of the sentence is the larger number, which is x, is 3 less than double the smaller number. So for this equation, I have the larger number, that's x, is represents my equal sign, and then I have 3 less than double the smaller number. Okay, if I'm 3 less than something, it means I'm subtracting 3 as my last step. And it's 3 less than double my smaller number. So I gotta be a little bit careful here, but this would be my second equation. The larger number is 3 less than double the smaller number. So basically, I would multiply first and then subtract. But now that I have these two equations, I can forget all of the context from these sentences and just focus on solving these. Now for solving a system of linear equations, we have the addition method, but this one's set up nicely to do the substitution method, where if x is equal to this, and I see this x sitting in my first equation, I'm just going to take this and plug it in place of x. That is, I'm going to take this stuff and put it right over here. So I'm combining my two equations down into one. I end up with 2y minus 3 plus y is 12. So what I did is I took my two equations and condensed them into one. Technically, the parentheses that I just wrote here, we didn't really need to write because there's only one that's in front of the x. So this is really 2y minus 3 plus y is equal to 12. I will combine like terms, so I get 3y minus 3 is 12. I will add 3 to both sides, and I get 3y is equal to 15. And after I divide both sides by 3, I get that y is equal to 5. So that would be my smaller number. Now that's halfway through. To complete this problem, I would need to know what the larger number is as well. So this is where I can go back to my first equation and plug in y is equal to 5. That is, x is equal to 2 times 5 minus 3. And if I simplify this, I get 10 minus 3, and that means x is equal to 7. So my solution in this case is going to be x is equal to 7, y is equal to 5, and it should make both of my equations true. That is, the sum of my two numbers is 12. That certainly is true. And if I double this number and take 3 from it, it should be equal to 7. Well, that's true as well. So let's use a system of equations to solve the problem here in example 2. So the idea is that there's a florist, and they have this budget of $500 to make bouquets of both roses and tulips, and it costs them $10 for the roses and $15 for the tulips. So if they want to have 44 total bouquets on hand, and they have this budget of $500, well, how many of each type of bouquet should they have? So for this, again, my starting point should be, let's define some variables. You can use any letters you want. I'm going to let R be the bouquet of roses. And I guess I'll let T be the bouquet of tulips. And once I have my two variables, it's a matter of now setting up two equations and then solving the system that we get. So with the given information that we have, it says during the first week they want to have a total of 44 bouquets on hand. Well, if this is the one for roses and this is the one for tulips, what we get here as an equation is R plus T is equal to 44. I just don't know how many of each. The second thing is that their total budget that they have to spend on these flowers is $500. Now here we need to do something a little bit extra. If R is the number of bouquets that they have for roses and it costs them $10 per bouquet, that means it's going to be 10 times R is going to be the total cost. So $10 times R is the amount they're spending on the roses. Similarly, it is 15 times T that they're spending on the tulips. And at the very end, they only have $500 to do this, so the sum of those two dollar amounts should equal 500 exactly. So again, we took the sentences, defined variables, created two equations. The goal is to now solve this system of equations. I think I'm going to use the addition method here. I see I have 10R. If there was a negative 10R right here and I added the two equations together, these would cancel. So my first step is going to be take the first equation and multiply it by negative 10. This is not the only approach you could take. I just think it'll work nicely for this problem. So if I do this, I'm multiplying through this equation by negative 10, and my result is as follows. Negative 10R, we get minus 10T is equal to negative 440. And this means I did not do a thing to my second equation. I left it alone, so that's 10R plus 15T is equal to 500. It's now set up perfectly for the addition method, where I'm going to add the left side and the right side and see what I end up with. The r's cancel. Negative 10t plus 15t is simply 5t. And negative 440 plus 500 is a positive 60. To solve for t, I'm going to divide both sides by 5. And I get my answer of t is equal to 12. The only other thing I need here is r. So this is where I, again, go back to, let's say, my first equation. I'll put 12 in place of t, and that allows me to solve for r. So let's do that. I have, again, r plus t is equal to 44. I'm going to put 12 in place of t and simply subtract 12 from both sides. And when I do, I have my answer for r. r is equal to 32. So we have our answer. The florist should make 32 bouquet of roses and 12 for the tulips, and that's the final answer.